Welcome back to our channel. My name is Teacher Smith and today we are going to understand the very important principle of half model. Now, to understand this model well, I have taken a question from 2022 SASMO question number 7. So, without wasting any more time, let's get started. Now, here the question says, in the square below, points E and F are the midpoints of AB and AD respectively. If the length of the square is 4 centimeter, find the area in centimeter square of the shaded region. Let's try to understand the question first. Here I have a square, that is square ABCD. Inside the square you can see a shaded region, that is FEBD. Now for the shaded region, is there a formula to calculate the shaded region directly? Currently, is this a regular shape to us? Do we know any formula? Now, some student will say it will looks like a trapezium. But do we know the formula to calculate area of this trapezium? Of course not. So, for me, it's still irregular shape. Now, how I can find out the irregular shape? Remember, whenever we have question based on irregular shape, we can try to include this irregular shape inside any regular shape. Now, is this shaded part inside any regular shape? Yes, it's given that it's inside this square that is present. So for the square, can we find out the area of the square? Yes. But to find out the shaded part, which parts we have to remove? Yes, we have to remove the part that is BCD and we also have to remove this part that is AEF. So here, these two are nothing but the triangles that are present. But how to find out the areas of these two triangles so that I can remove? Now, this is the part we need to understand. To understand it well, here let's say I take an example. Let's say this is a square. Now, in this square, I have a diagonal, let's say. Now, what I'm going to do is I'm going to shade one part of this square. Now, can anyone tell me what is the relation of the shaded part with the entire square? Yes, many of you will say it's half of it. Yes, very good. Now here what we can observe, the shaded part and the unshaded part are totally the same. So I can say that both the parts combine to become a square. So one part is just half of the square. Now if I take another example where instead of square I have a rectangle. But I have the same diagonal that is present and I am going to shade one of the following part. Now can anyone tell me what is the relation of this shaded part with the entire rectangle? Yes, again it's half. We can observe if I draw a diagonal, one of the part will be just half. Now this is something which we call it as half model, where we can understand if there is a diagonal that passes from the square or the rectangle, half of the shaded region below the diagram, you can say that it's half of the entire figure. Now it's only applicable for the squares and the rectangles that we have. But let's see one of the extension for the half model which can also be tested in our SASMO exam. So what is the extension? Let's have a look. Let's say I have a rectangle and I have a triangle inside it. Now we can understand here the base of the triangle is overlapping with one of the side of the rectangle. And you can also observe the tip of this triangle is touching the rectangle. Now if I ask you, what is the relation of the shaded part with this entire rectangle? Now some of you will guess that it's half. Now we don't need to guess. We have to confirm our answer. So how we can be assured? For this, no worries, Teacher Smith is here. What we can do is, here we have just seen for two of the following figures. Half model is nothing but from the diagonal I can draw a line. So here what I can do is, there is a tip that is present. And from this tip, if I draw a line, straight line which is perpendicular to the base, I can observe here the part that I have shaded. Let's say one of the following part. Can I see any similar part in this entire figure? Yes, we can see this part is actually equal to the other part that is present here. So these two parts are actually the same. Also, if I take another part of this triangle, that is this blue colored shaded, is there any part on the figure? Yes, it's the same part that is present in here. So what I can understand from here? These two parts are actually present over here. So what can I say about the shaded part and this other grey colored part? Yes, we can say they are the same. So, if shaded part, that is the colored one, is equal to this non-colored, I can say this colored one is half of the entire rectangle. Because the entire rectangle is made up of these two parts only. So, what we can understand from here is, here, if I have a triangle whose base is on one of the line and the tip touches the rectangle, remember the characteristic. Then I can say the triangle that is formed inside the figure is half of the rectangle. Now understanding this, let's quickly jump on to our question. Now our question has, in the square below, points E and F are the midpoints of AB and AD. So AE and AD. So what I can understand regarding this E? What can I say about this point E? Yes, they are midpoints. And if it's midpoints, I also know the side length of this square. That is, it's 4. So here, AE will be 2 and EB will be 2. So these two values we can easily get. Now, the question also says the length is just 4 centimeter. So, now can I find out area of the entire square? Yes, we can. And how to find out area of a square whose side length is 4? Yes, it's just 4 times 4. So let's calculate the area of the entire square ABCD. That is, area of quadrilateral ABCD is nothing but 4 times 4, which is 16 centimeter square. Now, if this is the formula for area, which two parts we have to remove? Yes, we have to remove this part and this part. Now, regarding the part that is triangle BCD, here this shaded part, how I can find out area of this shaded part? Yes, we learnt a model just now. Here, regarding the shaded part that is present, what is the relation of this triangle with the entire square? Perfect, it's just half of it. So I can find out area of triangle BDC is half of this square. That is 16 divided by 2, which is 8 centimeter square. So this part I know is 8. Now, to find out the shaded part, which other part we have to calculate? Yes, we have to calculate AEF. Now the question arises, how we can calculate the area of this shape AEF? Now most of the students will say we can find out this area using the formula for area of a triangle. But for those students who don't know how to calculate the formula for area of a triangle, here the explanation is. Now this is the shaded part. Now this shaded part is the triangle. Right now we learnt about a model where I can say that the shaded part is half of the square. But I have a shaded part. Is there any square that is present? No. But can I draw a square inside here? A is 2 and AF is 2. So can these two sides be the side lengths of the square? Yes, it is. So here, in order to draw the complete square, I need to draw a line from E. I need to draw a line for F. And if I draw, it looks something like this. Now, can I find out area of this square? That is, if I name it as O, AEOF. Can we find out this part? Yes, the side length is 2 centimeters, so the area is 2 times 2. So, let me write it down. Area of AEOF is nothing but 2 times 2, which is 4 centimeters square. So, if the entire square is 4 centimeters square, how to find out just AEF? Yes, AEF just half of this small square. So, I can write down area of triangle AEF is 4 divided by 2, which is 2. Now, I have area of the entire square. I have area of these two triangles. How to find out the area of the shaded part? Very simple. From the square, we just have to remove these two triangles. So, let's write it down. Area of the shaded is nothing but total 16 is present, and from this I have to remove this 8 and this 2. So, I can write it down 16 minus 8 minus 2, which is 6 centimeter. So, what we can understand from this question here? We understand a very important principle of half model. Regarding the half model, we can understand if there is a square or a rectangle and there is a diagonal that is present, we can say that the half of the diagonal, that is the shaded part, is half of the entire square. And how to find out the shaded part? Which principle have we used? Yes, we try to include the whole square, and then which parts we removed? Yes, we removed these two triangles. So in order to find out areas of irregular shape, we can understand, we can calculate it as whole and then remove the parts that we don't need. So this is what we can summarize. In order to find out area of irregular shape, we can use the formula that is whole minus extra, or whole minus the part. And how to find out the extra? What did we do to find out extra? Which model did we use? Yes, we use half model. So how we can find out the extra is nothing but by using half model. Now, if you have understood the question well, next week we are going to arrange a mock exam in our center. The date is mentioned here, that is on 18th March. Timing is from 3 to 4th. And remember, you have to come to our center to give this examination. If you are interested to sign up, you can scan the QR code on the poster to register yourself directly. Or else, if you have any other questions, you can scan the QR code above me. This is our study group and I can attend your doubts there. For now, I am Teacher Smith signing off right now, but I'll see you in the next video.